Hi guys, I just want to show you the demo I did in class for those who missed the class. So here you have the motor. Do you remember I show you how it works? You have a very strong magnet here, that's the north. Magnetic field come from the bottom to the top, right? And it's going through that loop here. And if I energize here the loop, so it means if I connect that to a power supply, you're going to have a current flowing. Okay, and the charge or the current or the conductor will be acted upon by a torque, such as if the current is flowing in this direction, you see it will align itself with the magnetic field coming from the magnet that goes from the bottom to the top. So it starts to spin and then it loses contact. So it's going to keep spinning. Okay. But now I'm going to do the opposite. Okay. So instead of using as an electric motor, I'm going to use it as a generator. So it's going to be a way to generate electricity. So what I have here, I can connect that to a multimeter. I don't know if you can see the multimeter here. It's a millivolt, and right now it has 0 millivolt, right? So the magnetic field is going through the area here that you can think it's like a soap film, right? So it's like an area attached to that loop here. And the magnetic field here, the magnetic field lines are poking through that area. But I'm going to spin the loop here. So what's going to happen is that the line going through the area here will change with time. Okay, so here we have 0 line going through, and then the line are going to increase. The number of lines, the magnetic field lines are going to increase, and then here it will be maximum, and then it's going to be decrease, it's going to be 0, and then the number of lines is going to be maximum and 0 again, right? By doing that, I'm going to induce an EMF. So that's Faraday's law of induction. So look up here, right? That's my multimeter. I am in millivolt, right? So if I spin not too fast, I'm already inducing about 5 millivolts, 8 millivolts. So if I spin very fast, you see I can get to 10 millivolts. And if I do it really fast, I can go to 12 millivolts, right? Since it's a closed circuit, I can also show you that I can induce a current flowing through the loop. So here I am at 200 milliamps, and you see you have induced current. It's because if you have induced EMF, you're going to have an electrostatic that will, not electrostatic, an electric field, okay, that will pull on the charge, and you're going to have a current flowing, right? So that's how we produce electricity in a power plant. So you change the orientation here of that loop, and that will be a generator. So a motor can be turned into a generator. Okay, so that's one thing. So I'm going to disconnect that. So again, the idea is that if you have to be able to produce a voltage, you need to have a magnetic field, a conductor, and something has to move. Either the conductor has to move, or maybe the area of the conductor has to move, or the orientation of the conductor relative to the magnetic field has to move, or the magnet has to move relative to the conductor. So we're going to see that in class. So here I told you if you want to have extra credit, you can do that very simple demo. So I don't know if you can see with the camera, but here I have magnet, neodymium magnet. So you have magnetic field coming from here, right? It's like a shooting out and then going into a circle back on the other side of the magnet here, right? And then here I have, it's like a coil, right? So this, here I have wire, and it's an enamel wire. So it means it's insulated. It has some kind of varnish. And then here you remove the varnish at the end here, right? You use a knife, for example, and you have a LED. And nothing happens here. But as you spin the magnet here inside the coil, the magnetic field here, lines are going to go through this area there, and it's going to change with time. So the number of magnetic field lines poking through this area, it's called the magnetic flux. And here it's maximum. Here is going to be 0. Here is going to be also maximum, but it will be negative. And here is going to be 0 again. So it's going to change with time. So the idea is that the magnetic field lines are going to cut through the conductor, the coil. So now see what's happening. I don't know if you can see with the camera. You see? You have little flash. So you can, you should be able to improve that system, but if you do it fast enough, yes, you see the light is going on and off. Now I can show you also here. I have the same idea. You have a little motor here, right? It's a toy motor. So if I I can energize the motor with a power supply. And I told you each time you work with coil, right, you want a lot of current. So that's why I use a long-term battery. It's only 6 volt, produce a lot of current. So I can power the motor here. And you see how it works. Now I can reverse, right? So here you turn electric energy into mechanical energy, but I can do the opposite, right? So I still use the motor. Inside the motor, you have the coil and the magnet. So you are moving the coil or you are moving the magnet relative to each other. And here I close the loop of the coil and I have a load, which is a LED, right? So it's a red LED. And you see that if I turn, now interestingly, if I turn the other way, if it doesn't get stuck, if I turn the other way, nothing happens. That's because LED is polarized, okay? The current can only flow in one direction. Otherwise, it does not turn on. And if the current tries to move in another direction, and nothing happens. So if I turn it the right, now it works, right? You have the same idea, like if you go camping, for example, and you run out of the battery, you run out of battery of you don't have any battery with you, you can use the hand generator like this one. So I don't know if you can see here, same idea. You have 2 coils, right? In that case, and you have a magnet that's spherical. And in that case, it's the magnet that's going to move relative to the coils. And here you can close the loop. So I can close the loop and I can add a load here. And here I have different LED. You see that each LED has to be protected with a resistor. And you have a red LED, doesn't take too much energy to light it and to turn it on. And then you have, I think, green, and then you have blue. And you're going to see that the blue one, okay, based on the quantum physics, so blue one will need more energy. So I have to work harder, right? So you turn mechanical energy into electric energy, and you are inducing an EMF. So for the red LED to work, you need at least 1.7 volts. For the blue LED to work, you need more than 2 volts, right? So first it's the red, I don't know if you can see, then it's the green. And if I do it very hard, you have the blue. The first one is infrared LED. So I'm not sure if, so first of all, you cannot see it with your eyes. You need a special sensor. But it takes little energy to make it work. So that's the idea. What is I want to show you? Oh, you can visualize also the Faraday's law of induction if you connect the motor here to a meter, so it's to measure the current. See here. So if I turn in one direction, the current is going to be positive. If I go very slow, I have very weak current. Now I go very fast, I have very large current. So if I turn the opposite, I'm going to have the current flowing in the other direction. Okay. So in class, I will show you a slide that from the 19th century when they, or beginning of the 20th century, late 19th century, when they started to do the experiment, they will use coil, right? Solenoid. So here I have two solenoid. So I'm gonna energize this one. Okay, so I'm gonna energize this one. So that means I'm gonna turn this one into an electromagnet. Right, so now I have an electromagnet. I'm gonna leave it like this. Okay, so I have my electromagnet here. And then I'm gonna connect that. I'm gonna connect the second solenoid here to my multimeter that I'm gonna use to find the current. Hopefully you see the number there. Well, so far it's 0. So I'm connecting this one here. And okay, I need to energize. So you see it can make a spark here. So if the connection is right, you should see that I can induce some current here, right? So it's an induced current. I can also measure the voltage, and you can see that I am inducing. So here you have the magnetic field lines going into a circle, but as I go inside, the magnetic field line are going to cut through the conductor. Or you can say you have a surface area attached here. So by going in, you increase the number of magnetic field line poking through. Going out, you decrease them. Okay, so you can see how it's not easy, but you can see that if I go really fast, I get about 2 millivolt. Oh, and I should disconnect that. So I don't know if the video worked very well, but just to give you an idea how Faraday's law of induction works.